This example comes out of section 9.1, antiderivative. This question where it has to find the most general antiderivative of f of x equals sine x cos x. We can't, hopefully you would think immediately, well, I can't just take the antiderivative of each part of that separately because, you know, we haven't learned how to do product rule backwards or something like that. So, you can't just take the antiderivative of sine, antiderivative of cos, and try to multiply them together, because what you end up with will not differentiate to give you this as an answer. One thing you could do is look at your formula sheet and realize that sine of 2x equals 2 sine x cos x. So this function could be rewritten as sine of 2x divided by 2. If you do it that way, that's probably the most straightforward way for where we're at right now with antiderivatives, given that we're in the intro lesson for it, that you know you would need a cos of 2x. You would need a negative, because if I differentiate cos, I get negative sine, not positive sine. And I would get times 2, but I want to end up with divided by 2, so I have to actually divide by 4. This would be 1, and probably the one expected of you at this point. One thing that I like this example for is it actually kind of foreshadows what comes much later on when we start to use something called substitution to do these. Another answer to this, and I don't expect you to be able to find this yet, relates to sine squared. If I gave you y equals sine squared as a function, hopefully you tell me that the derivative of that is going to be 2 sine x times cos x. Well, that's awfully close to what we have here. In fact, if I just take that and divide it by 2, I have a function that if I differentiate it, I will end up with sine x cos x. I still need plus a constant. These constants, it turns out, are actually different numbers, so maybe I'll call it C1 and C2 just so we don't get mixed up. Another way of thinking of it is to say, oh, what if I called it cos x times sine x? Well, if you thought about this as what's the derivative of cos squared, it would be 2 cos x times negative sine x, or in other words, negative 2 cos x sine x. So my antiderivative could also have been, cos squared, but I would need a negative, and I would need to divide it by 2 to end up where I started. If you take the derivative of this, you'll get now cos x times sine x. You still need a constant, and the constant turns out is different than these other two. Kind of an interesting example. It is way more advanced than what you need to be able to do in 9.1. I don't expect that to be there. But if you see a function and its derivative, like sine x and its derivative sitting there, it's actually a situation where it's almost like the chain rule in reverse. The same thing here. If I see, I've got cos x and its derivative essentially, which is sine x, I can think about this question in a different way. And it turns out all three of these would be antiderivatives that would work for that particular function.